afternoon, ladies and gentlemen. Today again we are getting into the new lecture concept of the descriptive statistics, and specifically the title is descriptive statistics, and we are looking at the graphical tools. Okay. And remember, in the previous lecture we have already talked about three aspects to determine which statistical test to use. The three number one was your independent variable, number two was your dependent variable, and number three was your descriptive statistics. And when we say statistical test, think about it as an arithmetic tool. You can think about it as an arithmetic tool for the time being. Okay. So, what we are trying to do today in this class is we will try to see a little bit of descriptive stats, okay, and one of the simplest tools that we are going to see in this case. So, this is the 9th lecture of this course, and we will start by looking at why graphical tools. Okay. Obviously, someone wise person once said a picture is worth 1,000 words. This is very true, especially when it comes in the statement of statistics. I could possibly say that I can modify this and say that a picture is worth 1,000 data tables or something like that, or data values. Okay. So, graphical tools really help you to visualize the data. And I said earlier, data comes in two forms. Number one, too much of data. Number two, too little of data. This is very true when it comes in the practitioner's case. Okay. This is always true in practical scenarios. You will never get the right set of data. You have either too much of it or you have too little of it. So, then you have to play around with it. Okay. So, once you gather the data, okay, and as I said earlier, you gather data on the dependent variable. Why? Because by collecting this data, you are trying to find the effect of independent variable. Okay. So, due to that, so once you collect the data, then what? Then what do you do? Okay. So, gathered data must be described and analyzed. Gathered data must be described and analyzed to produce summary information. So, once you collect the data, and then what you have to do, it must be described and analyzed. You should describe the data and analyze the data, through which you will end up producing what you call as a summary information. So, once you have summary information, then what? Then the best way to display the summary information or best way to communicate the summary information is using a graphical representation. Okay. So, the most effective way of communicating the summary information This is what we call as the graphical representation. So, if you say that the total budget of a, so let us consider that budget of college. Okay. Let us say this is, if somebody says the total budget is divided into, let us say 20% for salary, 20% for research, 30% for equipment, and then 10% for maintenance, okay, something like this, okay, and then the rest of the 20% for profit. Let us say, think about a scenario like this. Then displaying this in a pie chart would actually, this is like 20-20, and then you have like 30, and then 10 and 20, something like this. So, you basically say that, okay, fine, these are the equal portions of the budget and these are the two large areas. So, you can think about this as a pie chart, which is an easy way of displaying this information to somebody, which tells you the relative budget spending on each other thing rather than looking at a extensive list like this. Okay. So, in this class what we are going to do is, the first graphical tool we are going to study today here is called as the Pareto diagram. Okay. So, the Pareto diagram is an important tool and the Pareto diagram has quite a lot of aspects related to it. So, we will talk about what it is. Okay. So, before getting into the Pareto diagram, let us think about why organizations collect data. One of the main reasons for data collection is due to some failure in the system. Okay. Usually failure in the system triggers investigation. What type of investigation? Finding the cause of the failure. Finding the cause of failure. Okay. Then how to fix the cause. Then how to prevent reoccurrence of the cause. Who is responsible? So, these kind of things, okay. These aspects are the ones that triggers the investigation. This is kind of the triggered investigation and the outcomes of the investigations. From there, you use this to make decisions. Decision on how to sort out the problem. Okay. Most of the time, failure in the organization occur due to any of the 5 M's. The first one is man, okay, or human beings, machine, your resources, materials, raw materials, other things, money or what we call as finance, and method is what we call as the process. Okay. You can think about this in any organization as a set of 5 dials. Okay. Think about this as the man dial, then is the machine dial, or like kind of a dial, what I say, it's a regulator kind of a thing. Then there is a materials dial, then you have a money dial, and then you have a methods or a process dial, something like this. Okay, so this is your materials, money and methods. If you have 5 dials like these, you can think about changing these dials, okay, changing the dials in the system to change the performance of it. So, these could be your independent variables, and that results in, that would cause some failure in the system which you measure it in some other case. So, when an organization identifies a process or a method, okay, as a candidate for improvement. Why is it a candidate for improvement? Because it has caused the failure. Then the first step is to collect data on the frequency of failures, frequency of each type of failures or each type of failure. Okay. So, what does Pareto diagram do? Once you collect the data on each type of failure, then the Pareto diagram orders each type of the failure according to its frequency. Orders in a sense, it sorts, okay, into each type of the frequency and each type of the failure and its frequency. So, the type of failure and its frequency is being considered as part of when the Pareto diagram is the one that orders each type of failure according to its frequency, and then you can visualize how what are the major causes of failure and how is it impacting that. Okay. So, there is a principle behind Pareto, but before looking into that, let us look into this Pareto example. Okay. So, here is a trivial example, a simple example that we can work in the class itself. We do not need Excel or anything to do this, but you can use Excel if you want to, but a pen and paper would do. Assume that your factory has a CNC drilling machine and it is working below the expectations. Okay. So, this is what the problem is. What is the problem? CNC drill working below expectation. This is a failure. In a sense, it is a failure because you are not able to produce the amount of product that you want to produce. Okay. So, it is working below the expectations and the management wants to study the cause of it. Why is it? Okay. Why is the question is, why is the CNC drill not performing? This is the question. Okay. So, that is the cause. This gives the answer to this question will give the cause, okay, or the causes. There could be multiple causes. Okay. So, what the management did is it wanted to look into all sites of failures and their frequencies, and they interested the workers and the workers collected the data. The data is like this. Okay. There is a defect category and then the value. So, number one of the defect category is power fluctuations in the power to the machine, and it resulted in 6 failures. Then the number 2 is the unstable controller, the controller of the CNC. So, this controller means the CNC controller. Okay. The controller is unstable, it has resulted in 22 failures. Then the operator, the person who is operating the machine, okay, because of the operator error, the mistakes committed by the operator, it resulted in 13 failures. Then not being able to replace the tool in the proper time has resulted in 2 failures. And other things which could be like failure of coolant, not sufficient coolant, breakage of tool, some unexpected things which are bunched resulted in 5 failures. So, this is the data that is given to us, okay, and using this we will learn how to make a Pareto diagram. So, one of the first things is the empirical rule of Pareto, okay, and there is an importance with this, and the Pareto's empirical law, that what does it state? This law states that in any assortment of events consists of few major and many minor elements. So, if you take any assortment of events, okay, take a lot of failure events or whatever it is, it will consist of few major events and many minor elements. Okay. So, the major will be few and the minor will be large in number. It is also known as 80-20 rule, okay, which means 20% of or 20% of the events result in 80% of the issues, or majority of the issues are created by minority of the few major events. That is what the Pareto rule is. Okay. So, in practice, okay, because we are practitioners, in practice, typically 2 to 3 elements will account for more than half of the frequency, Okay. So, what we are saying here is, we are not really looking at the 80-20 perfectly as such. We will say that typically 2 to 3 elements in the assortment of the events will account for more than half of the frequency. So, let us see how this actually works out. So, why use Pareto? What is the importance of using this Pareto? Because it helps in finding few vital opportunities, for major improvements from a set of many trivial opportunities for minor improvement. So, what we are saying here is, it will help us to identify few vital opportunities that results in major improvement than from a many trivial opportunities that will result only in minor improvement. So, what we are looking for is the biggest bang for the buck. So, what does that mean is, what is the best maximum returns, okay? That is what we are trying to do. So, in this case, what we are supposed to do is, the first thing we need to do, we have to look into the data that we talked about. So, we had 5 of these data values, and the first thing for us to do it is, the step 1 to create the Pareto diagram is to sort the data in the descending order. Okay. So, what we do is, step 1, sort the data, what data? Failure data in descending order. Okay. So, what we do here is, so let us make a table out of this. Okay. So, here is the what we call as the failure category, and we have the value. So, if we go back, we will actually see that the largest descending order means the largest value first. So, this is the largest. Okay. So, then what we do is, we go back and we say unstable controller, it is 22, that is the largest value. Then the next largest value was the operator error, which is 13. So, we will say now it has operator, which is 13. Similarly, we have power failure, which is our power fluctuations, operator, it was operator error, power fluctuations, it resulted in 6 issues. Then others resulted in 5, and then tool, improper tool, it resulted in 2 failures. So, this is the descending sort. So, we can say descending value. Okay. And if you sum the total thing, it is 22 plus 13 plus 6 plus 5 plus 2. So, summation, sum of all observations is equal to 22 plus 13 plus all the way up to 5 plus 2, that is equal to 48. Okay. So, there are 48 total defects that were identified. Now, with this, the next thing is how do you do the Pareto diagram. So, the Pareto diagram is a graph, okay, is x axis and a y axis, and the x axis you have each of those defect categories being put here. So, we have 5 defect categories, 3, 4 and 5. So, the first one is the controller, okay. Second one is the operator, the third one was the power, fourth one was others, then the fifth one was tool. So, each one of the category, so the category of failure goes into the x axis, and the y axis is, you can think about it as the count or number of failures, okay, that goes in your y axis. So, it starts at the 0, and let us think about it as the maximum value is 25. So, we will say 5, 10, 15, 20, 25, 30, it goes like this. So, then the first observation of the controller failures was up to 22. So, we assume this is up to 22. So, we draw a rectangle here, we say this value is 22. Okay. So, the 22 failures are accounted right here in this one. Then the next one is the operator, which resulted in 13. So, somewhere here we draw a line and then we draw a rectangle, and this is the 13 of the operator failure. Then we have the power failure, which was at 6. So, 5, 6 is slightly bigger. So, this is 6. Then others was 5. So, slightly lower than this. Okay. And the last one was the tool, which was 2 of them. So, it is a small rectangle. So, this diagram typically will say that this is the simple Pareto diagram. Okay. Now, in this case, you remember we had a table, and the table had failure cause, value. So, we had controller as 22, then operator as 13, power as 6, others as 5 and tool as 2, and we summed all of this, sigma was equal to 48. So, if you look into this, okay, then the relative frequency. So, here it will be 22 divided by 48, which will give you 0.458, okay, and this will be 13 by 48, which will give you 0.271. You can do the math by yourself. This value 6 by 48 will give you what you call as 0.125. The 5 by will give you 0.104, and this will give you 0.042. And if you sum all of these, the values will come to 1. So, the idea here is that if you look at this, okay, then you can think about this particular fashion. This is one way to do this, the count. The other way to do the Pareto is also this fashion. Okay, if you assume it as a cumulated value, you can think about it as the count 1, 2, 3, 4 and 5. Same thing, your controller, operator, power, others and tool as the 5 factors, and you can think about it as your the individual observations going right here, 10, 20, 30, 40, 50, 60, 70, 80, 90 and maybe somewhere here is the 100, let us put it this way. And so the controller is 45 or 0.458, which means 45.8. So somewhere here will be the controllers. Okay. So this is like the 45.8%. Then the operator is 27.1%. So that is someplace here is the operator, which is 27.1 percentage. Then power is 12.5 percentage. So somewhere here is the 12.5 percentage. The others is the 10.4 percentage. So it's like little bit less, 10.4 percentage, and the tool is the 4.2 percentage. Okay. So something like this, 4.2 percentage. So now if you look in this case, okay, so the this is the 45.8%. But if you look at the second one, operator, okay, so the controller contributes to 45.8 percentage of failures, okay, and then operator contributes to 27.1% of failures. Okay. So if you do both of these, it will be 9, 12, 72.9 percentage of failures by both. Okay. So as we studied or as we looked in the Pareto principle, what did we say? 2 to 3 of events resulting in more than half of the problems. Okay. So same way, if you look into this, you can say that these two guys put together, okay, results in greater than 50% of the issues. So for you or for a decision maker, then it will say that okay, the decision will be from here is, so what will be the decisions? The decisions will be, number 1, replace the controller chip or whatever it is, or find a better controller chip. Number 2, train the operator. That could be one decision, or hire a new operator. Okay. So these kind of things, by looking into this, you can say that by solving these two cases, by dealing with the controller and by dealing with the operator, about 72 point or 73%, approximately 73% of the failures can be addressed by dealing with this. Okay. So this kind of a approach where you can either look in the count. So here you are doing the count and here you are looking at the frequency or the percentage of the percentage contribution to the failure. Okay. You can think about as a frequency, or you want to call it as relative frequency, or you want to call it as a percentage of failures, whatever it is. So the y-axis will have that and the x-axis will have the category of failures. So these are the two ways you can do the Pareto diagram. For most of the this is done for what you call as typically mostly done for survey like data where you use the count, and mostly done for engineering like systems. Okay. So, in a hotel you might want to find out how many people actually do come. So, this count might matter to them, whereas in an engineering like system the percentages might matter, the absolute count might not be of much importance. So, depending upon how the systems turn out, you end up making the appropriate choice of the making the Pareto diagram. And such a Pareto diagram can be easily made with the help of Excel. You don't need any complicated tools to make these kind of Pareto diagrams. Even in that case, the worst case scenario, a simple pen and a paper and a calculator will do the trick also. So, I hope that you guys understood the concept of Pareto diagram, which helps us to identify the few vital causes that actually results in majority of the problem, and addressing them rather than focusing on the minor ones that actually gives very minimal returns. So, this is where the focus is on the biggest bang on the buck, and then identify how to deal with it. Thank you.